My name is Sohan Maheshwar. I'm a dev advocate with a startup named Fermyon. I spent my last 6 years at Amazon Web Services, AWS, working on cool cloud stuff. And today, I'm going to tell you what the future of cloud is. And that, folks, is WebAssembly. Has anyone here worked on WebAssembly before? Anybody? A couple of people, excellent. So we are here to talk to you about why WASM, or WebAssembly, is the future. First off, I know this is a very bold claim to make, right? I'm just walking on stage, random person you've never seen before, and I'm telling you the next wave of cloud computing will actually be powered by WebAssembly, right? So I know it's a bold claim to make, but stay till the end and hopefully you're convinced. But if you don't believe me, you can actually see this tweet by this guy named Solomon Hykes. And he says, if WASM plus WASI existed in 2008, we wouldn't have needed to create Docker. Solomon Hykes is the guy who was part of the team who invented Docker. He's known as the person who invented Docker. So I think he has something to do with seeing what tech works in the future. So of course, this tweet is part of every WebAssembly presentation you'll ever see because it made such a big wave, right? And I thought I'll also quickly add it up there. Today, I'm essentially going to tell you about what WebAssembly is, how it works, how and where you can actually use it with a quick demo with an open source project. And I'll talk about how this will change things in the cloud and how this may affect you in your companies. Right? So a bit of history now. WebAssembly, the boring answer is it's just another bytecode format. Right? It's another portable format of things that you can run somewhere, right? Eventually, it's all zeros and ones. But how is it different, you ask? Well, essentially what happened in around 2015 was a bunch of companies got together, and they decided they wanted a new format, right? And this format was meant to run things in the browser much faster and more safer. And essentially, they came up with WebAssembly. And WebAssembly has a smaller instruction set. It's much more of a low-level language, so it's faster. Right? And it's designed to be portable, which means it can run anywhere. Originally, it was meant to be run in the browsers. In fact, you still have companies like Shopify, Figma, Adobe, who use WebAssembly for their front ends for it to be faster and safer. But it can also be used outside, which is what I'm going to talk to you about. Essentially, it runs on a compile once and then run in any number of targets sort of model, as long as it has a runtime that can run WebAssembly. Now, the slightly older folks in the room, like myself, might be like, hold on, isn't this like JVM or Java virtual machines? And conceptually, yes, it is, in the sense that you write this once, you can run it anywhere. But the key difference, we think, is that JVM is proprietary, whereas WebAssembly is not. It's a technology. It's a standard. Anyone can use it. And of course, it is security sandboxed by default, which I will talk about in a bit. And a quick FYI, WASM WebAssembly, same thing, right? It's the exact same thing. How it works is, like I said, you have some code. And that code can be converted into a WASM format, which can then be run anywhere, right? So you can run it in any machine that has a WASM runtime. And this could be a Mac, this could be Windows, Linux, Intel, ARM, AMD, Kubernetes, Raspberry Pi, cloud, whatever. You can run it as long as it has a WebAssembly runtime, right? So that's one of the big advantages. Just to give you an example of this, here's an example, but only I've just used screenshots of how a Rust app is actually running in the browser with JavaScript, right? So you can see Rust code there. The first line is something called wasm_bingen. That essentially is a library that facilitates high-level interactions between WASM modules and JavaScript, right? So using that, you can have access to the DOM, or the document object model. There's just some text and a small calculator at the bottom, right? Don't have to worry about it too much. We have JavaScript code that actually can send values to this particular Rust code that's written there. You can see the tree and the source code. You see there's a TS file, there's a JS file, there's a Rust file. And this can actually run in the browser, right? Now, some of the things that made WebAssembly really good in the browser were what I just mentioned to you. Right? It is cross-platform, it is cross-architecture, so write it once, it'll run anywhere. By default, it is security sandboxed, which means any WebAssembly module, nothing can access that module unless you give it specific permissions, right? Unless you explicitly say that, OK, you can access this HTTP host or this file, nothing can access that WebAssembly module. So it is security sandboxed by default. Also, the binary sizes are very small because it's very low level. And at the same time, it's a reduced instruction set. So the execution time and the startup time is very fast. And ideally, it can support any language. All of this makes it good for the browser, but it actually makes it great for things on the server. Because at some point of time, I think around 2019, people were like, hold on. All of this will make WebAssembly amazing if you can run it on the server. The thing, though, is if you want to run something on the server, you need to give it access to files. You need to give it access to things like sockets and networking and clocks and random number generators. Right? So in 2019, something called WASI was launched, which is a new kind of system interface. It's WebAssembly Systems Interface. And the TLDR essentially is it allows you to run WebAssembly outside of the browser, i.e. on a server. Right? And suddenly now you have this new way or this new idea of running WebAssembly in the browser, in the server. What it does is it gives you access to OS features like files, file systems, clocks, random number generators. It's completely independent of any web API or any JavaScript, so you can run it in the server side. And the security sandboxing also includes, the WASM sandboxing is also extended to include the I/O. Right? So the same security model has been preserved. Just to give you a recap, you have JavaScript runtimes, of course, like V8 and SpiderMonkey, that allow you to run WebAssembly in a browser. But now you have these new runtimes, like WASM Time, WASM Edge, and also an experimental Node.js runtime to start running WebAssembly on the server side. Just for some context, this is the evolving language support in WebAssembly. This is a page that constantly evolves, and I have to always change my slide because people like me, I work in Fermyon, but also other companies like Fastly and Microsoft work together with different boards and foundations to get support for WebAssembly in different languages. So it is something that is constantly evolving. Lower-level languages like Rust, C, C++, of course, have better support because they are lower level, whereas languages like Python, JavaScript, TS, all of them TypeScript, the support, I think, is still in a state of evolution and will definitely get better moving on. So I've given you this overview of the history of WebAssembly and why you can now run it in the server. How can you actually get started by building your first WebAssembly app? Right, and getting started with WASM. So I work at a startup called Fermyon. Basically, the founders of Fermyon, about, I think, a year ago, started writing an open source project called Spin. And this caught fire online. Currently, I think more than 4,000 stars on GitHub, huge community, Discord, all of that, where people essentially write libraries to build WASM apps using Spin. And we are trying to build the developer experience around building WebAssembly apps. So Spin is the open source framework. It's an open source tool. It consists of libraries, templates, and a CLI. And you can just create WebAssembly apps if hosted wherever you want using Spin. Right? So I can show you a quick demo of going from nothing to creating a Spin app just using 3 commands. Right? And hopefully this works. You know how live demos go. So I'll say a small prayer to the demo gods first. I've already installed the Spin. Oh, wait. I need to move. We already started. Hopefully you can see my screen. Yeah, there we go. Yeah, so I've already installed the Spin CLI. So all I have to do is say something like Spin new, right? And this gives you a bunch of templates for you to get started easily. Now, for any WebAssembly app on the server side, we envision something that is always event-driven, right? So anyone here familiar with serverless computing? Anybody? Lambda Azure? Yeah, many of you all. So something very similar where there is an event that this particular WebAssembly app gets, and then some code actually runs. Now, that event could be anything like HTTP, which is the first few examples you see. It could be a Redis trigger as well. It's open source, so people have written triggers from SQS, Simple Queue Service. People have written triggers from MQTT. But I can show you a simple example that is in HTTP and in Rust. So we can do that. I can give a name. So let me say Rust_shift. Right? Description. A HTTP base is basically a route. So if you do something.com/rust, this particular app will be triggered. So we'll say, sorry, that's the path, and that's it. So let's see how that actually looks. CD. Oh. Yeah. OK. So basically, what this does is it creates something called a cargo.toml file. If you're familiar with Rust, you know what that is. And it creates another manifest file called spin.toml. Right? And we will look at that now. Essentially, this is the entry point to your Spin app, right? And hopefully, you can see it. A WebAssembly app and a Spin app is made up of multiple components. And in this case, you have just the one component that you've defined here, which is what you can see. In this component, you define an ID, line number 9. You also define the allowed HTTP hosts. Like I said, WebAssembly, by default, security sandbox model. So if you want to say only xyz.com can trigger this particular WebAssembly module or component, you can mention that in the allowed HTTP hosts. In this case, of course, we put a star, so anything can trigger it. But you can specify which hosts are there. Right? And you can see below, this is the route. But you can also specify a route when this particular event is triggered. And of course, the source code is super simple because this is a simple router. So it is a request-response model. A request comes in, line number 9, and a response goes out. Right? We can actually just change this to hello shift. Let's see how that goes. So this is my Spin app that I've created using Rust and WebAssembly. If I do spin build, this builds this particular app locally. It uses cargo and all of that to build the app locally. And you will see that it creates a .wasm file, which is the WebAssembly module that can actually run anywhere. So once this is done, and it took about, 10 seconds, you will see here, right, there are files here that are created that can actually be run anywhere. So let me actually test this out locally, right? And all I have to do is spin up. And this creates a local server. Oh, sorry. I think I have something running already here. Oh, Control-C. There we go. Yeah, this has actually created this locally for me to test it out. Yeah, you can see this here. So I have a local dev experience for me to test out my WebAssembly app. Now, we want to build the entire dev experience from building a WebAssembly app to pushing it out into production. So Fermyon, we have a cloud product as well. So I've integrated my CLI with the cloud, which is a one-click thing through GitHub. So all I have to do is just say something like spin deploy. What happens now is this app is going to be pushed to the Fermyon cloud, where it is actually live and in production. Of course, this is a simple hello world app. But even with this app, you can see that in less than 66 seconds from start to end, you can have an app running in the cloud using WebAssembly. Right? And yeah, there you go. That's the address. You can also bring your own custom domains to this for now, right? So here you go. Yeah. So this is an app that's live in the cloud. It's in production. So we've built the sort of end-to-end experience for building out WebAssembly apps. I'm going to switch back to my presentation right now and talk about why this is so important, right? And it is because of few things, of 4 things specifically. The first one is the size of your binary file. Now, all of us are devs. I think we frequently talk about things like optimization and improving things like packet size, binary file sizes. In Rust alone, a typical Rust hello world compiled to WebAssembly is only 2 MB, right? If you do it natively, that's typically about 3.1 MB. And if you compile it ahead of time to a particular architecture and OS, you can bring that down to 300 KB, right? Which is really, really small. And that makes it that much more efficient in terms of resource utilization. At the same time, a basic spin HTTP API that I just showed you, the just-in-time compilation is 2.3 MB, and the ahead-of-time compilation is about 1.1 MB. Right? And these things make a difference when you're actually serving customers in the millions and doing things at scale. The next one is startup time. This is the trade-off between binary size and startup time. If you compile a program in Rust natively, it is a little faster. So actually running it is about 2.3 times slower than doing it natively, right? So it is a trade-off that you as a developer or as an architect have to sort of think of making. In terms of portability, I said again, you can build this once, you can run this anywhere, and the same build sort of works across OSs and across platform architectures too. And like I mentioned, security, by default, it is sandboxed. So you don't have to worry about external things accessing your modules or your functions that are actually running because it's default sandbox security. So I've given you an overview of the history of WebAssembly, why it's good in the server side. How will this really change cloud computing, though? I think most of us work in the cloud at some level or the other. How will this change in the future? I think it'll change things gradually and suddenly. Two ways that I see it change cloud computing, but we have to look at the sort of progression of cloud computing in the last few years. I think we all started with the heavyweight, which is virtual machines, things like Amazon EC2. These were entire OSs that were running in quote unquote, somebody else's computer, right, running in the cloud. And these took minutes to start. As a dev, you had to do updates, maintenance, patches, all of that. So the dev experience wasn't great, but it introduced us to new forms of computing in the cloud. I think sometime in the mid-2010s, things changed to containers with Docker and Kubernetes. Here you had applications which had dependencies, but you never had it's working in my local system, but not in production, right? Because you are shipping things in a container as well. This takes about a few seconds to start, so it's much faster. But at the same time, the developer experience is good, but it can be complicated. I think anyone who's managed an entire Kubernetes toolchain will agree with me that it is kind of complicated. The sort of shift everyone's talking about now is the shift towards serverless, right, with things like Azure Functions and Lambda, where everything is completely event-driven, and things take milliseconds to start. And as a developer, you don't have to think about patching, maintenance, scaling up, scaling down, and you're paying only for the time your code is running. The thing with the current day of serverless is there are still some problems which we intend to fix with things like being platform neutral and building a good dev experience. So let's talk about a bit of both right now, right? Let's talk about containers. Containers can be clunky sometimes, right? If you've used Docker and you have a huge Docker image for a simple program, you know what I'm talking about. We actually tried doing one of those things, and I'll show you the benchmark. But this is the follow-up tweet to the original tweet, which is, so will Wasm replace Docker? The answer is no, right? But it will probably run alongside a Windows container and a Linux container, or it might replace it, but there's still space in the world for containers. How we see it basically is this, that it is a fast friend with containers. So here's an example of a Flask app in Python running on Docker, and the same thing sort of built using WebAssembly. Right? This is the visualization of the size of the Docker file that's built using Flask, whereas this is the same program using WebAssembly. Right? And we also did a benchmark, and the size difference was 23 megabytes to 550 kilobytes. Again, as programmers and architects sort of optimizing on processes and resource utilization, these things make a big difference. So we really see containers and Wasm working together to, again, make that container size smaller to be a little more efficient, right? Docker Desktop 4.21 onwards supports Wasm. It's still in, I think, beta/preview mode, but there is support. You can also run Spin on Kubernetes. There is support on Azure AKS. There is a module called KWasm that does this. And we're working with many other Kubernetes providers to actually have full support for Spin. So there may be instances where your workloads might actually benefit from moving to a WebAssembly that's running in a container somewhere. So that was the containers bit. Let's talk about actually fixing the current state of serverless. I love serverless. I think serverless is amazing and definitely the way to go. In terms of widespread adoption, it still isn't as widespread as, say, just cloud computing. So we're still seeing enterprises adopt serverless. The thing with serverless is the definition is still quite hazy. So we like to think of it as a pattern for coding where the developer like you does not write a server process. So you're not writing a socket or a daemon. Yeah? And the entry point usually is an event. Now, in the serverless world, there are a few things that can be improved. And the first thing that people talk about in serverless is cold starts. So essentially how this works is when an event hits a serverless function, say in Lambda or Azure, that program has to be started up, which takes a finite amount of time. And in applications where that is critical, devs try very hard to reduce those cold start times. Because we've been able to run it on WebAssembly, which has a smaller instruction set, a smaller binary size, it can have pre-compiled code, it has a lightweight runtime, the cold start time has actually reduced from 250 milliseconds on Lambda to around 50 milliseconds on WebAssembly and Spin. Yeah? And that, I think, is a fairly significant difference. So thanks to how WebAssembly is architected, thanks to how Spin is architected, you can bring those cold start times down to quite a bit. All right, so cold start is one problem. The sort of big problem we see when we talk to customers about serverless is the fact that big companies are afraid of something called vendor lock-in, where you are locked into a public cloud because you're using their serverless offering. Because there is no famous non-proprietary framework around serverless. If I'm not mistaken, there are a couple open source ones. They don't have widespread adoption yet. But essentially, this is how typical computing in the serverless world looks. If you have a function in Azure Functions, your other serverless functions are also in Azure Functions. If you have it in AWS Lambda, then you're talking to other AWS Lambda functions, and your microservice architecture is built around that. Or if you're a little more low level, your container is in like an OCI, Open Container Initiative, or Kubernetes, or you're running it on a virtual machine, and you're just stuck doing that. Right? We want to sort of move away from this proprietary, locked-in type of serverless in the open source space. So essentially, we think that WebAssembly opens this up for y'all. And the last thing about serverless, and I'm going to give you an example of how it fixes vendor lock-in and this, is that you can have more than one language in your app. So imagine you're writing a microservice architecture where one microservice is in TypeScript and the other is in Rust, and it's talking to something else that's in Python, right? And WebAssembly can actually make this possible, and I'm going to show you a demo of that right now. The demo I'm going to show is something that I'm super excited about. It's called the component model. And you'll probably hear about this in a bigger way very soon, because it's something that's being worked on by the Bytecode Alliance, right? That is the alliance that's working on the standards around WebAssembly. So essentially, in a component model, you can use a component from anyone in your app. So say I'm writing a serverless microservice app, and I want to use a key store, key value store. I can use someone else's key value store without knowing how that operates. Someone else can use an authentication component that I write without knowing how it particularly works, right? And WebAssembly allows for that. So how that would work is you have these things called worlds. Right? So I have a component, and in this component, I want a WebAssembly module component for HTTP requests and for a key value store. But I don't want to write my own, so I can just use someone else's HTTP server component and a third person's key value store component in my own app. Right? And this becomes part of my world. So this component model, we think, will really open up how microservices and serverless truly is written. Of course, you can try it out. It's already live, but you will see a lot easier and better dev experience around it in the coming months. Right? Spin, the open source framework that you saw a demo of, already has something like this, where you can export components for usage elsewhere. And yeah, instead of me explaining this to you, I can actually just show you a quick demo. Right? This demo, again, is super straightforward in what it does, but how it does it, I think, is very impressive. Right? So let's take a look. So this is a simple key value store. I can add a key and a value. Right? Again, very simple. Oh, I'll have to start the server, so just give me a second. I'm just starting this up locally. Yeah, there we go. So this is my key value explorer. I say conf shift, right? And it's added it to a local key value explorer. It's just a simple key value. Don't worry too much about it. And I have a web page that's running here, which essentially I can call a service, and it pulls up that same value. Right? So this is a simple CRUD database app. It's not very impressive. But let me show you the code behind this. As you can see in not this code, yeah, this is the code. There's actually a Rust file talking to a TypeScript file to get this done. Right? What you see, which I think, again, is impressive. So if you see the front end for this, the time I press the first button, it actually get and set a value from my Rust file here. Right? So I set the value using my Rust file, and I got my value from the TypeScript file here. Right? And again, this is the future we sort of envision with a microservices architecture. If you look at our, like I said, the manifest file here, there is a component which is a Rust component, which has a route, and it has a key value store. That key value store is automatically synced to an SQLite database that is triggered here, and that talks to my TypeScript component. Right? So I have a Rust component talking to a key value store. I have a TypeScript component talking to an SQL database, and those two are talking to each other in the same app. So I've exposed all of that using WebAssembly. And this, we think, could be the future of how cloud computing actually works, where you're focusing on the core business logic, the dev experience is great, and the cold start times are very minimal. In terms of the sort of use cases that this actually opens up, I just showed you things in the cloud like functions as a service, but also things like plugins for user-defined functions in databases, or bring your own code in a SaaS platform. Say you have a SaaS platform like HubSpot, and you want to bring your own code that runs a webhook somewhere, or a Slack bot somewhere. This is ideal, because you have the very fast execution times, very small binaries, and you can write it in different languages. And in things like IoT, you can run WebAssembly on the edge as well. Again, in smaller IoT devices, which will run and make it a lot faster. So it really started to open up so many of these new different use cases once Vazi was done. Anyway, hope you learned something about the WebAssembly world. I'd love for you to check it out. Spin is open source. We have a Discord and a GitHub, vibrant community around it. So if you do coding in any language, you can get into building in WebAssembly, because, well, that's the point, I guess. So do check it out. And yeah, I'm here for the rest of the conference if you have questions. I have some stickers and T-shirts in the front if you want to grab some. There are limited ones. And yeah, thank you for having me.